Welcome, wonderful people. We are going to look at implicit differentiation, just focusing on solving the problems. So in exercise 3.7, they say differentiate implicitly. Use implicit differentiation to find dy over dx in exercises 1 until 14. So the first one, they say x squared y plus xy squared, it's equals to 6. So what is it that we do here? Implicit differentiation, dy over dx of x squared y plus dy over dx of xy squared equals dy over dx of 6. Now remember, we are differentiating everything with respect to x. So this will require the product rule. So you will hold on x squared, differentiate y, plus hold on y, and differentiate x squared. I'm applying the product rule here. Plus, this will also require the product rule. I will hold on x, differentiate y squared, hold on y squared, differentiate x. And the derivative of a constant is 0. Very important. So I'll have my x squared. The derivative of y is 1, but I'm writing dy over dx because this alphabet is not x. I hold on y. This is 2x. And I'm writing 2x without writing dy over dx because the alphabet is x and I'm differentiating with respect to that alphabet. I have my x, differentiate to y, dy over dx. You understand what I'm doing now, I know. Plus hold on y squared, differentiate this, and you get 1. So here I can have my x squared dy over dx, plus I can have 2xy plus 2xy dy over dx plus y squared is equals to 0. Group the dy's and the dx's together. X squared dy over dx plus 2xy dy over dx. This is equal. Take this to the other side, minus y squared. Take this to the other side, minus 2xy. Now what you need to do is to factor out dy over dx. You have your x squared plus 2xy minus y squared minus 2xy. Divide your dy over dx minus y squared minus 2xy, x squared plus 2xy as your dy over dx there. So you will find your dy over dx as minus 2xy minus y squared divided by x squared plus 2xy. Just a nice simple problem that requires just somebody with a very good basic. So let's just continue in this. Now I'm going to look at number 3. I don't know whether I'm going to solve 5 problems or 10. I'll just see. Where I get tired, I'll just stop. So we have a 2xy plus y squared equals x plus 1. So the same procedural method applies. Dy over dx of 2xy plus dy over dx of y squared, dy over dx of x, dy over dx of 1. Then from here I can factor out 2. Very good. Plus the derivative here is 2y dy over dx. This is 1 plus dy over dx. And then from here I can apply the product rule. Hold on x, differentiate y, dy over dx, plus hold on y, differentiate x, you get 1 plus 2y d over dx equals 1 plus dy over dx. Multiply 2x dy over dx plus 2y plus 2y dy over dx, 1 plus dy over dx. Group the dy's and the dx's together. 2x dy over dx, 2y dy over dx minus dy over dx. You have 1 minus 2y. Remember, this is this goes to that side, it's this. And in here, what is it that we can do? We can factor out dy over dx, 2x plus 2y minus 1, 1 minus 2y, dy over dx, 1 minus 2y, 2x plus 2y minus 1. I think that should be the solution for this problem. 1 minus 2y, 2x plus 2y minus 1. Such a very simple problem. Remember, I'm a man who deals with the basics. Now let's go to something that might seem difficult but very easy, and let's see how we can do it. Number 5, we have x squared, x minus y squared equals x squared minus y squared. Right. How do we do this? In problem number 5. Right. I think what we should do in this one is just basically to do the following. I know that I'm going to apply dy over dx in x squared, x minus y squared, dy over dx of x squared minus dy over dx of y squared. And the biggest challenge is this one. So I'm going to hold this and try to differentiate that. But if I try to use that method, can you see that this becomes a little more complicated? So let me not apply dy over dx first. I rather simplify this. So x squared, x minus y, I'm repeating this 2 times, equals x squared minus y squared. Right. And let's look at something here. Let's try to wait a bit. What is this? This is a difference of 2 squares. Can you see that? Yes, it is. So I can rewrite x squared, x minus y, this is x plus y into x minus y. X squared minus xy plus y, xy minus y squared. Can you see that? X squared minus xy plus y squared plus xy, they cancel, minus y squared. So what I can do, I can divide by x minus y, so I'm left with x squared, x minus y, which is equals to x plus y. And now I can implicitly differentiate this. So don't rush first to apply the definition, try to simplify first. Be that as it may, I can now work on this, and I can use the distribution here so that I have x3 minus x squared y, that is equals to x plus y. Can you see that? Now I can work on this. Dy over dx of x3 minus dy over dx of x squared y equals dy over dx of x plus dy over dx of y. Very good. And then from here, what is it that I can do? I can do the following. I know what needs to be done. I can say 3x squared, very good, minus, so this would be the product rule. Hold on x squared, differentiate y, you'll get dy over dx. Hold on y and differentiate this, you'll get 2x. Very good. Equals, and then this is 1 plus, and this is dy over dx. Okay, so let me just use the negative. 3x squared minus x squared dy over dx minus 2xy equals 1 plus dy over dx. Let's group the like terms. Minus x squared dy over dx minus dy over dx, you have 1 plus 2xy minus 3x squared. Factor out dy over dx minus x squared minus 1 plus 2xy minus 3x squared over minus x squared minus 1 equals your dy over dx. So in number 5 we have let's check this. Is there any other thing that I can do there? Let me check. Minus 3x squared plus 2xy plus 1. Let me check something. .7. Let me check. We had number 1, number 3, and now we are at number 5. And there seems to be a different answer for this. There seems to be a different answer for this. But everything seems to be done quite well. But I don't know why there's a different answer for this. Okay guys, let's simplify this further. So we have, let me show you something. We have minus 3x squared plus 2xy plus 1. So what is it that I can do here? But I think we are fine if we just leave it at this. I think we are just fine. But I'm open for any discussions. We can discuss this, but it seems very correct. So let's go to number 7. Y squared is equals to x minus 1 x plus 1. So we can say dy over dx of y squared equals dy over dx of x minus 1 x plus 1. So this is 2y dy over dx. I'm going to apply the quotient rule. I'm going to hold on x plus 1 y over dx of x minus 1 minus, I hold on x minus 1 dy over dx of x plus 1, divide by the denominator squared. So you have 2y dy over dx, that is equal. So I'm having my x plus 1. If you differentiate here, the derivative of x will be 1, and the derivative of a constant will be 0. Very good. Minus x minus 1. The derivative of x is 1, and the derivative of 1 is 0. X plus 1 squared. 2y d over dx. This is the same as x plus 1 times 1, which is x plus 1, minus into this times this is x minus 1 all over x plus 1 squared. And this is the same as x plus 1 minus x plus 1 x plus 1 squared. This into this goes once, 2 x plus 1 squared. Remember, this is 2y d over dx. You divide it by 2y. D over dx is 2 x plus 1 squared times, and then the reciprocal of 2y is 1 over 2y. And this into this goes once. You are left with 1 over y x plus 1 squared is the solution for this problem. 1 divided by y into x plus 1 squared. Very good. And then let's go to number 9. Y is equals, x is equals to sec y. Okay, so dy over dx of x equals dy over dx of sec y. Now let me bring very close my table of differentials, because when you differentiate sec, you get sec 10. So the derivative of x is 1, and the derivative of sec y, it will be sec y 10y. Very important. Now the question is the following here in number 9. So we have 1 is equals to sec y 10y. That is the derivative. The derivative of sec y will be this, but remember we're writing dy over dx because this is y and we are differentiating with respect to x. So where do we go from here? That is the question. Where do we go from here? Right. So meaning if I divide by dy over dx, I'm going to have 1 over sec y 10y equals dy over dx. Okay, so 1 over sec is 1 over cos, times, and 10 is sine y over cos y, and this is equals to 1 over this times this is sine y, and this times this is cos squared y, and this in turn is 1 multiplied by the reciprocal, that will be cos squared y all over sine y, and that could turn out to be cos squared y all over sine y, and that could turn out to be cos y all over sine y, and that could turn out to be cos y over sine y times times cos y over 1. What is cos over sine? That is cot y times cos y as our final answer. This is very, very important that you see this. Highly and highly important. Okay, that was number 9. Let's go to number 11. So we have x plus 10xy is equals to 0. Okay, so what do we do from here in number 11? So dy over dx of x plus dy over dx of 10 xy equals d over dx of 0. So this will be 1 plus. Now, what is the derivative of 10? The derivative of 10 is 6 squared. Hold the angle. Now differentiate the angle now. Now when you differentiate the angle, let me just do this very, very quickly. Let me just do this. So what is going to happen here? You will hold on x, differentiate y, dy over dx plus, hold on y and differentiate x, you get 1, that is equals to 0. 1 plus 6 squared xy, and you will get x dy over dx plus y equals to 0. You have 1 plus 6 squared xy x dy over dx plus y 6 squared xy equals to 0. Now check what I've done here. This multiplies this and you get this. This times that and you get this. Very important. So this one, 6 squared xy x dy over dx, take this to the other side, minus y 6 squared xy, take this to the other side, minus 1. So you have this, there it is, this and that. Okay, so what are we doing from here? Right, I can say I can divide by 6 squared, so that dy over dx is minus y 6 squared xy minus 1 all over 6 squared xy. Okay, so I can divide I can divide this and this by that. I can do that, and the question is, how do I do that? That should be the question. So what I can do, I can say minus 1 sec squared xy. I can divide it by sec squared xy minus 1 over sec squared xy, and look what is happening. You have minus y. Very good. Minus 1 over sec is 1 over cos squared. 1 over cos squared xy. So this in turn it's minus y minus 1 times the reciprocal will be cos squared xy over 1. This is very, very important. Am I not forgetting anything in here? Ish, guys, I've made a mistake. Look what is happening here. There's an x here. I'm sorry. I'm very sorry, guys. I forgot that x. I'm sorry. I'm very, very sorry there. So there's an x here. I'm sorry, wonderful people. X and x. I'm very, very sorry, guys. There's an x there. There is an x there. Now it is disturbing me. So there is the x, so I divide here. I'm getting an x, and I'm dividing where again here. Okay, so I know that there is when I say this into this, I'll be left with minus y over x. Ish, I've made a mistake. Can I please start over? I'm very, very sorry. I've made a mistake, and this is going to confuse us a lot. I'm sorry, guys. I've made a mistake there. I forgot that x. I'm very, very sorry. Let me just start afresh very, very quickly. I am so sorry. Right, let me just draw up a line very quickly. And remember, we are busy dealing with number 11. X plus 10xy is equals to 0. Let me just check if this is what we are dealing with. Yes, I think so. Let me check. Where is that paper? Yes, we are dealing with this. So dy over dx of x plus dy over dx of tan xy dy over dx of 0. So this is 1 plus the derivative of 10 is sec squared. You hold the angle and then you differentiate the angle, the product rule. So you will hold on x, differentiate y, so you'll get dy over dx plus hold on y, differentiate x, and then you get 1. The derivative of 0 is 0, and then we have 1 plus sec squared xy times x dy over dx plus multiply here, you will get y sec squared xy. This times this is this, and this times that is this, and this is equals to 0. So I can have this x sec squared xy d over dx, that is equals to y sec squared xy minus 1. Right, and then my dy over dx will be y sec squared xy minus 1 over x sec squared xy. Okay, then from here I can divide everything by this. Y sec squared xy, I'm dividing by x sec squared xy minus 1 over x sec squared xy. This into this goes once, and I'm left with y over x minus 1 into x sec squared xy. Okay, that is fine. So remember, this is my dy over dx. Now I want to simplify this. And when I simplify this, I can have an LCD of x sec squared xy. This into this goes once, this times this is y sec squared xy minus 1. But let me see how they put it. They are not writing it in this form, so let's continue in this. So what I can do from here, I can work out this. This is y sec squared is 1 over cos squared xy. That minuses a 1. Remember, we are here. The numerator will be this. Divide x times the denominator would be 1 over cos squared xy. Very good. So from here, what I can have is the following. I can have y over cos squared xy minus 1. Divide, I can have x over cos squared xy. And what I can do in here is to say cos squared xy y minus cos squared xy, divide in here. So I am dividing. I can change division to multiplication so that I can have cos squared xy all over x. Okay, now look what is happening. Cos squared xy, this into this goes once. I'm left with y minus cos squared xy all over x. And I think this is what they should have. Minus cos squared xy, let's check, minus cos squared xy minus y over x, y a minus, y a minus. Why should there be a minus? Because I have this, multiply, I get that. This into this goes once. This times this is this. Very good. Minus there it is. This into this goes once. 1 times 1 is 1. Very good. I rewrite this as this minus 1. I rewrite this as that. Very good. So from there we have y cos squared xy minus 1 over 1. We have this. Very good. And from there, LCD, which is this into this goes once. 1 times y is y minus this into this goes this times 1 is this, times the reciprocal of this, there it is. So I get minus cos squared xy plus y divided by x. This is what I find. Okay, and then from there, let's go to another one, which is number 13. And we find y, the sine of 1 over y, that is equals to 1 minus xy. And then from here, what is it that we can do? I think what we can do, can you see my mistake here? Can you see my mistake? When I take this to the other side, this should be negative. Can you see my mistake? That should be negative. So this should be negative. So you are going to end up with a negative here. This is the mistake that I have done. This is a very, very serious mistake. There's a minus there. So meaning I will have this, 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 and you end up with this. I'm very sorry. I'm very sorry. These mistakes happen. They happen. They are just little mistakes that everybody can do. But now I can see that the memorandum reveals an answer with a minus, and I don't have a minus, and I try to check. I find there's no problem. But when I go to the original one, I trace and I see, oh, when this goes that side, I should have written a negative. These are the common mistakes that everybody can do. But at the end of the day, I was able to recognize those mistakes. And I'm going to post it as it is because I am not cramming anything here. I am doing these things based on my knowledge. So there will be mistakes here and there, but at the end of the day, they will be corrected. Okay, that is fine. And then where do I go from here? So this is one that I have, and I want to apply implicit differentiation. So how do we go about doing this? That is the question. Right, what we will do in here is the following. I will say dy over dx of y sine 1 over y equals dy over dx of 1 minus xy. Ndabezeta, can you do this? Of course I can do this, but it would require some work. So what I'm going to do now, this is implicit differentiation mingled with the chain rule. So I'm going to hold on y and I'm going to differentiate sine 1 over y. Very good. Plus I'm going to hold on sine 1 over y and I'm going to differentiate y. This is the chain rule, the product rule. I hold on y, I differentiate this, plus I hold on this and I differentiate that. So d over dx of 1 minus d over dx of xy, the product rule. Okay, so I have my y and I differentiate this. So the chain rule tells me what is the derivative of sine, its cos. Hold the angle. Now differentiate the angle. This is the quotient rule. So I'm going to hold on y. Differentiate 1, I get 0 minus. Now hold on 1. Differentiate y dy over dx. And now divided by y squared. So let me do this. Very, very important that you see that. So remember what we are saying here. What is the derivative of sine? That is cos. Hold the angle. There it is. Now differentiate the angle. Now this is the quotient rule. You hold on y, you differentiate 1, you get 0 minus. You hold on y, you differentiate y, you get dy over dx divided by y squared. Very good. Plus I hold on sine of 1 over y and I differentiate y, I get dy over dx equals the derivative of 1 is 0 minus, and I have a product rule again. hold on x, differentiate y, dy over dx, plus hold on y, differentiate x, you get 1. I right. And then when we are here, I'm having my y, I'm having my cos 1 over y, and I'm here. I'm going to have 0 minus dy over dx divided by y squared. Okay, plus here I'm going to have dy over dx sine 1 over y, that is equals to minus x dy over dx minus y. Okay, so what is it that I can do here? I'm going to focus on this. So I'm having my y, I'm having my cos 1 over y. Remember, 0 minus dy over dx is minus dy over dx. So I'm having minus dy over dx for here. And that dy over dx is being divided by y squared. So I can just divide this by y squared. Very, very important. Plus dy over dx of this. Dy over dx of sine 1 over y. Okay, let me get this. And this is equals to minus x dy over dx minus 1. Minus x dy over dx minus y. Alright. And then from here, you have, remember, this is multiplication in here. 1y cancels 1y and you are left with 1y. So you will have cos 1 over y. In fact, this will be, because there's a negative there and there's multiplication here, you will have minus cos 1 over y dy over dx divided by y plus d over dx of sine 1 over y, that is equals to minus x d over dx minus y. And when we are here, what is it that we can do? I can multiply throughout by y. Can you see that? So that minus cos 1 over y d over dx plus d over dx sine of 1 over y times y, because I'm multiplying everything by y, I'll have minus xy d over dx minus y squared. And then from there, what is it that I can have? I can group the like terms. I can take this to the other side. Minus cos 1 over y d over dx plus xy d over dx minus y squared. So I'm done with this. I took this to the other side. Done with this. I'm having this. Done with this. I forgot to write this one. So let me just say minus cos 1 over y d over dx plus xy d over dx. It's on the side already, so it is positive. D over dx sine of 1 over y, and this is equals to minus y squared. This is fascinating stuff. Right, and then when we are there, I can factor out dy over dx, and I will have dy over dx. I will have minus cos 1 over y, which is this one, plus xy, which is this one, plus y sine 1 over y, which is this one, that is equals to minus y squared. So dy over dx is minus y squared minus cos 1 over y plus xy plus y sine 1 over y. Is this true? Let's check. Minus y squared, correct. Y sine 1 over y, correct. Minus cos 1 over y, correct, plus xy. So we are 100% correct. And I will see you in part 2 of implicit differentiation. So let us continue, guys, and let's look at problem number 25. We say we have 3 plus sine y, that is equals to y minus x3. And I know that the derivative, okay, let me say d over dx of 3, d over dx of sine y, d over dx of y, minus d over dx of x3. We already know this. 0 plus the derivative of sine is cos y, d over dx, d over dx minus 3x squared. Take this to the other side. 3x squared d over dx minus cos y, d over dx. 3x squared equals d over dx, 1 minus cos y. 3x squared 1 minus cos y equals d over dx. I think that should be the answer for dy over dx, but remember we are looking for d squared y over dx. So d squared y over dx squared, that would be d over dx of 3x squared minus 1 minus cos y. Okay, by the quotient rule, I'm going to hold on 1 minus cos y, differentiate this to get 6x minus, hold on 3x squared and differentiate this. So the derivative of cos is negative sign, negative by negative is positive. So sine y d over dx. Okay, and then we divide the whole of this by 1 minus cos y squared. 6x 1 minus cos y minus 3x squared sine y d over dx all over 1 minus cos y squared. That is fine. And then I know that dy over dx is this. So I'm going to say 6x 1 minus cos y minus 3x squared sine y, 3x squared 1 minus cos y, all be divided by 1 minus cos y squared. And then from there I can have my 6x 1 minus cos y minus, please be very careful, I can multiply here, 3x squared multiplied by 3x squared, that is 9x4 sine y. Please be very careful, this multiplies with this divided by this. This is highly and highly important. Highly and highly important. So let us look into this very closely. You have this, there it is, minus. You are simplifying this. This times this is this, multiplied by that, divided by this. So this is over 1. And all this is being divided by 1 minus cos y squared. You can take out an LCD on this one. 1 minus cos y. Right. And then from here, this into this goes this time, multiply by that. You get 6x 1 minus cos y squared. Okay, this into this goes once. Remember, we have a minus. So we are saying this into this goes once. 1 times this is exactly that. 9x4 sine 1. And you divide by this. So I'm going to change the division to multiplication. 1 over 1 minus cos y squared. And then from this, 1 multiplied by the whole of that, that is exactly that. 6x 1 minus cos y squared minus 9x4 sine y. This times this, 1 minus cos y exponent 3. And I think this should be the answer. 6x 1 minus cos y squared minus 9x4 sine y into this. And we are done for number 25. Do we still have time? I hope. Let's go to number 27. So number 27, we have, they say, if x3 plus y3 equals 16, find the value of d squared y over dx squared at the point 2 and 2. Okay, d over dx of x3, d over dx of y3, d over dx of 16, 3x squared plus 3y squared equals to 0. Sorry, I forgot to write dy over dx. 3x squared plus 3y squared d over dx is equals to 0. And take to the other side. So d over dx will be equals to minus x squared over y squared. Right, I think this is correct. You take this to the other side, it becomes minus 3x squared, and then you divide, you will get minus x squared over y squared. So d squared y will be d squared y over dx squared. That would be d over dx of minus x squared over y squared. I can factor out a negative and find d over dx of x squared over y squared. I don't have a calculator, but I know I can use the quotient rule. I have my minus, so I can hold on y squared, differentiate this 2x minus, hold on this, differentiate that 2y d over dx, and all this divided by y squared squared. Okay, so I can have my minus in out there, 2xy squared minus 2x squared y d over dx is minus x squared over y squared divided by y4. And this could be negative 2xy squared. Negative by negative, it's a positive 2x4y all over y squared times 1 over y4, and I can take out an LCD. Y squared, and what transpires from here? What I can do from here, this into this goes this time, multiply by that, 2xy4 plus 2x for y multiplied by 1 over y4, and we would get minus this times 1 is exactly that, this times this is y6, multiply, you would get in fact you don't have to multiply, you can just plug in the values in there. So you'll have minus 2, your x is 2, your y is 2, 2, 2, 2, to that, and I don't know what value you will get there. When I multiply numbers of the same basis, I add the exponent. This is 2, 5, 6 plus 5, 6 all over 2, 6, and this is minus 2, 6, 2, 6 plus 2, 6, 2, 6, and you get minus into 1 plus 1, which is minus 2. I don't know if this is correct because I don't have a calculator, but I think it is negative 2, and you are done. Guys, I think I'm going to break it here. I'm tired. I will see you next time.